A single grain of rice. That's all it took to feed an empire Spain refused to see. The conquistadors arrived in the 16th century. They saw terraced mountains and dismissed them as primitive farming. They wrote reports calling the locals backward. Those reports were spectacularly wrong. Here's the staggering reality. The Ifugao people engineered a hydraulic system spanning roughly 2,000 square kilometers. The network fed an estimated 500,000 individuals across generations. And the Spanish? They never understood what they were looking at. Part 1 covered the terraces themselves. Now we go deeper, literally. Beneath those famous rice paddies lies something the colonial records barely mention: a hidden infrastructure of underground canals, stone-lined tunnels, and gravity-fed distribution systems that would challenge modern civil engineers. The data points are remarkable. Some tunnels stretch over a kilometer through solid rock. Water flow rates maintain consistent pressure across elevation changes exceeding 1,500 meters. The entire system operates without pumps, without metal tools, without written engineering manuals. How did they do it? Look, the answer starts with a man whose name Spanish records never bothered to preserve. Oral traditions call him the first Mombaki of the waters, a priest-engineer hybrid, someone who understood fluid dynamics through observation rather than equations. Think about the problem he faced. Mountain water is abundant but chaotic. The rainy season brings floods, the dry season brings drought. Rice requires precise water levels at specific growth stages. Too much water kills the roots, too little stunts the grain. Now pay attention. The solution required controlling nature itself. His innovation was deceptively simple. Instead of fighting gravity, use it. Instead of storing water in vulnerable surface reservoirs, hide it underground. Instead of centralized control, distribute responsibility across every family in the village. The tunnel system emerged from this philosophy. Water enters through intake points near natural springs. Stone channels carry it downward at carefully calculated angles. Too steep and erosion destroys the tunnel. Too shallow and sediment clogs the flow. The optimal gradient? Roughly 1%. 1 meter of drop per 100 meters of length. Here's where the engineering gets genuinely impressive. The builders achieved this precision without surveying equipment, like say no theodolites, no laser levels. They used water itself. A filled bamboo tube shows level through surface tension. Move it along the planned tunnel route, mark the consistent height, connect the marks. Primitive? That's applied physics. Think about it. The tunnels themselves reveal a sophisticated understanding of material science. Inner walls feature carefully selected stone. Porous varieties near water sources allow filtration. Denser stone in transit sections prevents leakage. The joins between sections angle downward, shedding sediment rather than accumulating it. One archaeological survey documented 17 distinct stone types within a single 200-meter tunnel section. Somebody knew exactly what they were doing. But the technical achievement only tells half the story. The social engineering matched the physical engineering in complexity. Consider the maintenance problem. Tunnels collapse, channels clog, walls crack. Who fixes them? Modern infrastructure relies on government agencies. The Ifugao created something different. Each family held responsibility for specific tunnel sections. Knowledge passed from parent to child. Repair techniques stayed within lineages. The system created distributed expertise across the entire population. No single point of failure, no dependency on centralized authority. The Spanish colonial administration couldn't comprehend this model. Their worldview required hierarchies, kings and peasants, masters and servants. They searched for the chief engineer, the supreme ruler, the commanding authority. They found farmers who politely explained that everyone shared the work. This confused the conquistadors profoundly. Their reports labeled the system disorganized, chaotic, evidence of a primitive society lacking proper governance. The reality was opposite. The Ifugao had created something beyond Spanish comprehension, a sophisticated distributed system resilient against the very centralized collapses that plagued European infrastructure of the same era. Now comes the twist that changes everything. There's a catch. The terraces started failing after Spanish contact, not immediately, gradually. The colonial administration introduced new concepts: individual land ownership, cash crops, wage labor, and lowland mines. Young men left the mountains. Knowledge transmission broke. Tunnel sections lost their designated caretakers. Within 3 generations, portions of the 2,000-year-old system began deteriorating faster than at any point in recorded memory. The Spanish had accomplished through economic disruption what no natural disaster ever achieved. And here's the haunting detail. Some administrators noticed. A handful of colonial reports from the 18th century express puzzlement. Why were the terraces degrading? The natives seemed less capable than their ancestors. Perhaps the earlier Spanish observers exaggerated the system's sophistication. The truth was simpler and sadder. The Spanish broke the maintenance culture without understanding it existed. They attributed the resulting decay to inherent native inferiority rather than their own destructive policies. This pattern repeats across colonial history worldwide. Disrupt indigenous systems, watch them fail, blame the indigenous people, use the failure as justification for further colonial control. The Ifugao case provides unusually clear documentation of the process, but the story doesn't end there.
Something remarkable happened in the 20th century. The systems started recovering, not through government programs or international aid, through cultural revival. Elders who remembered the old ways began teaching again. Young people who'd left for cities returned. The distributed maintenance model reactivated across remote villages. Modern measurements show water flow efficiency approaching historical levels in sections where traditional practices resumed. The tunnels work again because the social system works again. The numbers reveal something profound about technology and culture. A physical system cannot survive without its cultural operating system. The Spanish could map every tunnel and still miss the essential mechanism. The people were the technology. Contemporary engineers have attempted to document the system using modern methods. Satellite imagery reveals surface features. Ground-penetrating radar maps underground channels. Drone photography captures terrace geometry. But the most valuable data comes from conversations with elderly Mumbaki who learned from their grandparents, who learned from their great-grandparents. Their knowledge doesn't fit neatly into engineering databases. Water behaves differently when the moon position shifts. Certain springs require specific rituals before drawing water. These sound like superstition to Western-trained engineers, except the practices work, measurably, consistently. One researcher documented a traditional timing system for tunnel maintenance. The schedule seemed arbitrary: lunar phases, seasonal markers, ritual calendars. Then she mapped it against erosion patterns and sediment accumulation rates. The traditional schedule optimized maintenance efficiency better than her computer models. The ancestors weren't primitive, they were empirical. Thousands of years of observation encoded into practices that appeared irrational to newcomers who lacked the context. This realization has profound implications beyond the Philippines. Indigenous engineering knowledge worldwide may contain solutions invisible to conventional analysis. Climate adaptation strategies, water management techniques, sustainable agriculture methods, all dismissed as primitive by colonial observers who couldn't recognize what they were seeing. The Ifugao tunnels stand as a corrective, a physical monument to systematic underestimation. Spain called them primitive because Spain could not understand them. The real question is what modern civilization still fails to understand.
The terraces remain on the endangered heritage list. Climate change alters rainfall patterns. Youth migration continues. Traditional knowledge still struggles against economic pressures. But the tunnels keep flowing. Water still follows the ancient gradients. Families still repair their assigned sections. 2,000 years of engineering, 5 centuries of colonial dismissal, decades of near collapse, and still, the rice grows, the water flows.
What secrets remain in those tunnels? Researchers are only beginning to map the full network. Some sections haven't been surveyed since the American colonial period. Others were deliberately hidden during Spanish times and never revealed afterward. Local traditions speak of chambers, meeting places, storage areas, ritual sites, all connected to the water network, all underground, all waiting. Part 3 will go where the researchers haven't, into the chambers, into the rituals, into the secrets the tunnels were built to protect. Some knowledge was never meant for colonial records.